Okay, so we are up to chapter 9, estimation. And in this chapter, I'm going to give you a method that's going to let us estimate a population parameter, specifically the population mean or the population proportion. Because remember, realistically, we usually don't have access to an entire population. So we wouldn't be able to calculate a population mean or a population proportion. But what we could do is we could take a sample and we can use the sample mean, let's say, right, to estimate the population mean, and we could use a sample proportion in order to estimate the population proportion. But we always have to keep in mind that when we're estimating something, it's not going to be exact, right? And sometimes it might not be a great estimate. Sometimes it could be off. So we're going to talk about how we could use probability in order to be confident that we're coming up with a good estimate for these unknown parameters. So let's do a little bit of an intro. So the first bullet here says that occasions arise in business, social science, medicine, and in science when it becomes necessary to estimate a population parameter, such as a population mean, a population proportion, or the population standard deviation. So in most real-world practical applications, the true population parameter is unattainable since populations are large and it's either impractical or impossible to obtain the entire population data to calculate the true population parameter, such as the population mean or a population proportion. So we've said this before. In such instances, then becomes necessary to take a random sample from the population. And we could use sample data to estimate the population parameter that's unknown. And the process of using sample data to make an inference about a population parameter is called statistical inference. And that's that second branch of statistics that I mentioned in chapter 1. So remember, the first branch was descriptive statistics, and the second is inferential statistics, where we're going to use sample data in order to make inferences about a population. So the formal definition of estimation is right here. It's the statistical procedure which uses sample information to estimate the value of a population parameter, such as a population mean, a population standard deviation, or a population proportion. So what we're going to calculate is a point estimate. Whoops, let me get my highlighter. So a point estimate is a sample estimate of a population parameter, like I said before, such as a population mean or a population proportion. We might want to estimate those two. And we could get a point estimate, and that's expressed by a single number. So now let's think of a sample mean X bar as one method used to obtain a point estimate of the population mean mu. So in other words, we can take a sample and use X bar as an estimate of mu, right? Because typically mu is unknown. And we can also use p hat, the sample proportion, to obtain a point estimate of the population proportion p. So if p is unknown, we could use p hat as an estimate. So the sample mean and the sample proportion formulas are called estimators. And an estimator is a method or a formula used in estimating a population parameter. So let's look at an example. Example 1 says, a survey of 2,690 musicians showed that 368 of them are left-handed. Find a point estimate for P, the population proportion of musicians that are left-handed. So if P stands for the population proportion of musicians that are left-handed, we would need to know how many people are in the entire population and how many are left-handed, right? In order to calculate P. But I don't know how many people are in the population. All I have is a survey. A survey is a sample. So we're working with a sample of 2,690 musicians, and 368 of this sample are left-handed. So we could say that X equals 368 of them are left-handed. So we can't calculate P, but I can estimate P, right? I can estimate P using P hat. So P hat is an estimator of P. And remember, the way we get P hat, or the sample proportion, is we take X and we divide it by the sample size M. So if we take 368 left-handed people divided by the 2,690 people that we surveyed, that's going to give me the proportion. So 368, and you could do this along with me in your calculator. So 368 divided by 2690 to 2 decimal places is about 0.14, or 14%. So that would be our point estimate, P hat. And we could use that as an estimator of P, the population proportion of musicians that are left-handed. So let's do one more example, example 2. A researcher wishes to estimate the mean resting heart rate for long-distance runners. A random sample of 12 long-distance runners yields the following heart rates in beats per minute. So here's my data set. So I actually gave you a data set in this case. So this represents the 12 heart rates for the people in the sample. So the question says, use the data to obtain a point estimate of the mean resting heart rate for all long-distance runners. So again, we're trying to estimate mu. That's the mean heart rate for all long-distance runners. But I don't have data on all the long-distance runners, right, for the whole population. This is just a sample. And my sample is size 12. So N is equal to 12. So what I can do is I can use X bar, the sample mean, as an estimator of mu, which is the true population mean. And you guys know how to get X bar, right? We could either do it by hand, add up all the data values and divide by N, which is 12, or we could plug the list into the calculator, do one variable stat. And that's what I'm going to do. It's just quicker. So if you want, you can pause here, enter that data set into your calculator, and find the mean. And when you unpause, you'll see my calculator. I already entered the list into my calculator. So I have all these heart rates in L1. So we remember how we do a one variable stat. We press stat, we go over to calc, we choose one var stats. List should be, for me, L1. You put whichever list you used. Now remember, frequencies list has to be empty. So just clear that out. Make sure there's nothing under frequency list. And then we could calculate. And X bar is 68 beats per minute in this case. So that's going to be our estimate. So BPM, beats per minute. So my estimate is going to be X bar equals 68 beats per minute. So this was just a quick lesson, a little intro on how to estimate parameters that are unknown. Specifically, how can we estimate mu, the population mean, and how can we estimate P, the population proportion? And we figured, okay, we can use X bar as an estimate of mu, and we could use P hat as an estimate of P.